Hello, everyone, and welcome. I'm really pleased to introduce Øystein Haldorsen. He's the technical director of Bilfinger rotating equipment in Nordics. And today I get to learn, along with all of you, about electrical discharges in lube oil systems. And just before that, I want to put up the code, so make sure you do the play to win and get that code in. And without further ado, here's Øystein.
Hello, everybody, and welcome to this virtual summit session. Topic for this session is electrical discharges in lube oil systems. I'll try to give it a practical seen from a practical point of view. But first, let me introduce myself. My name is Øystein Haldorsen. I'm the technical director for Bilfinger rotating equipment. I live in Norway, age 50, and have about 30 years of experience within chemical and petrochemical industry and oil and gas. And I've been working both on client side and as a service provider. What we're trying to cover briefly today is the why. Why do electrical discharges occur? And how to detect them? And what we can do to solve the issue. Discharges releases a lot of energy, and this energy breaks down the oil molecules and creates a lot of varnish. And this is the main problem we see on client side these days. The buildup occurs when oil flows through small clearances as nozzles and oil filters, and that's because of the friction between the oil molecules themselves and the oil and the surfaces. It's been flow rate, viscosity, temperature of fluid influences the hydraulic load. Higher load gives more static electricity buildup, and low conductive fluids like lube oils give higher charges. Higher charges give high energy discharges as sparks. On the picture here, you see a process pipe on a client, from a client of us. This is the return pipe from the bearings from a process gas expander. This machine had been in operation for 20 years with no problems between overhauls at all. Then the client decided to replace the oil. The current oil was being phased out, so they decided on a new oil, which was better, practically much better oil than the oil one. But after a couple of months, they have started to have problems with the high bearing temperatures. And then this thing occurred. Yeah, as you saw on that film, you saw those discharges, and of course this breaks down a lot of oil into varnish, and this varnish ends up on the cold places as the oil coolers, and it gets stuck in the bearings as varnish as well, and yeah, causes a lot of problems. The quality of the base oils is getting better all the time, really. Basically, the clients are in demand for more long life lube oils. And when the base oils are getting better, there's the sulfur content in the base oils are almost gone, and no olefins in the base oils. And that gives less polar molecules in the base oils, which gives lower conductivity. And also the additive packages is constantly being modified, most due to environmental reasons. For example, zinc, which help giving the oil higher conductivity, is now almost gone. The conductivity of the oil is getting lower and lower, and low conductivity gives higher static charges. On the picture on the side here, you see it's from Sasaki's video from 1992. I think it's the first time that spark discharges were filmed. This was a return pipe to an oil tank, and you have the discharges when the oil went into the oil tank. How to identify discharges? When we are talking to clients and they have a machine setup where they have problems with high bearing temperatures and high vibrations after an oil replacement, we ask them to check for varnish content. If high, then discharges might be the root cause. We have seen when replacing bearings that there are damages to bearings and shaft due to discharges. But this can also be due to arching from shaft to bearings. And that's another problem area which we will not be covering today. But if there's a sign of arching to the shaft as well, there's a possibility that the discharges is from the oil. If the machine system is equipped with probes and a system 1 or similar system, you can look for spikes in the waveforms and the orbits. You see spikes here and here and here. If you see spikes in the waveforms, there is a possibility that you have electrical discharges of your bearings. And it's also possible to detect it by using a charge collector to measure the amount of electricity charged into the oil. We have never used this ourselves, but we know that a lot of times when this has been a valid solution to detect this problem. This picture is from a root cause analysis we did last year. It was a syngas train, had been in trouble-free operation between overhauls for close to 15 years. And same story again. Client decided to replace oil. The oil was replaced with a new type. And after a couple of months, they had problems with the bearing temperatures and vibrations and had to run on decreased load. They asked us to do a root cause analysis, and the train was stopped to replace oil and bearings. We took oil samples from the used oil and took the bearings back to our lab for analysis. And what we saw straight away after cleaning off the varnish was that you had this frosted area here on the bearing, and that's the load zone. Frosted areas on the journal bearings indicates arching. That was confirmed when we looked into this area with a microscope. We see several points here where there's melted babbitt metal, and especially this big one here where you have a quite visible area where the white metal has melted due to extremely high temperature. That's arching. On this one, we also saw the shaft had severe arching. And also in an extent that we saw that it had taken off small metal pieces of the shaft. And that's all what you see on the bearing here, that the pieces of metal from the shaft has gone into the bearing and done damages to it. Discharges will often happen in the oil filter, especially if the machine is run with the filters that was the filter types that were installed when the machine was new 20 to 30 years ago. We ask our clients to listen to their filters. If you hear a very distinct crackling sound from your filters, then you have discharges within them. Especially during startup, we advise clients to follow up their filters, because before the oil reaches its operational temperatures, if you have discharges, then it's very easy to hear that crackling sound. And we also have clients that have run into problems just by basically doing what is the right thing to install better filter elements. And but then, of course, then you increase the hydraulic load. And also, we tell our clients that they should pay more attention to the differential pressure over their filters. Even suggest to lower the alarm limit, and be quick to switch over to standby filter, so you keep the hydraulic load as low as possible during operation. How you not will want to identify your discharges. There have been reported several fires in systems where the root cause has been discharges in oil systems. This has especially been during startup, when the oil filling up the system and decreasing the level in oil tank draws in air. And if you're unlucky and you get an explosive mix of oxygen and oil fumes on the top of your oil tank, and you have a discharge, yeah, that can be bad. The discharges can also happen outside the system. I've seen that myself. It can harm personnel, and in most process areas you have AX areas, and you don't want to have an ignition source within these areas, of course. What can be done to solve the problem? The fast solution is to, if you have the possibility to run both filters in parallel, that decreases the hydraulic load instantly. We tell clients that if they are in doubt, to be sure, run filters in parallel during startup until the temperature is up. And if they have to wait for new filters or better solutions or time to do something, even install filter elements with higher microns. As a permanent solution, do a root cause analysis to ensure that the problem is what you suspect. Do a full verification of the grounding, both the earth grounding and the earth bushes on the shafts. And start to check what kind of second generation anti-static filters you are able to install. With the right type of elements, you can reduce the electrification up to 100 times and basically remove the problem forever. But first of all, we try to advise our clients to do a full analysis of their system before they do the oil replacement. It might cost some, but it's sure it's cheaper than a non-planned production stop. Thank you for your time. If you have any questions, don't hesitate to contact me. Bye.
Øystein, that was awesome. Thanks so much. And I know that we have some questions lined up for you.
Yeah, I lost your sound here. Sorry.
Oh, can't hear me?
Now I can hear you.
Okay, good. So we have a question from Rahul. Essentially, so can electrical discharge issues happen in a system which don't have VFD? And how will it reflect in vibration and oil analysis?
We have seen it in basically all kind of systems, really. I read some reports from drilling, the drilling sector, where there have been a bunch of fires in the breathers on the small hydraulic systems out there. And yeah, wherever you push oil through a filter, this can happen.
So in terms of, what's the most likely application where this phenomenon is seen?
Yeah, where we see it is basically on mostly on a bit older systems where they are introducing better and better oils, and they come to a point where these filters that were working very well with that oil 20 to 50 years ago now have problems with the new oils. So basically, when you replace oil without taking into account that the filters need to be looked after as well, we see that the client runs into problems.
Got it. And we have a question from Dr. Quick. What type of deposits are mainly created in ESD? Is it more like sludge or more like carbon particles?
Yeah, what we've seen is the typical sludge buildup in the coolers, and and of course in the bearings you get the more of the carbon lookalike particles.
Excellent. And so I had a question about the filters themselves. So you're saying there's the causes, let's say, are from older filter technology with newer oils in the older systems. And you mentioned running parallel filters. Are there particular types of elements that are recommended to stop ESD?
Yeah. What we do when we try to help out a client when we have identified this problem is basically to verify what type of elements they are able to install in their existing systems, and find a type that is designed for that particular oil they are running on currently. And basically it has to be a specialized filter for that oil and that operational point.
So you have to match. You have to be a matchmaker, right? Finding the right element for the oil for the application, right? Because it's a balancing act between, that the filter technology, the rating, right? The micron rating is you don't want to take anything out of the oil that's supposed to be there. Okay, excellent. And we have a question from Saeed. Thank you. So what are the effects of ESD on the filter elements, and what can we see on the filter element that indicates the presence of ESD?
When we have looked at a couple of elements where we have heard that distinct crackling sound from the elements, and what you see when you look into those filters with a microscope is, you see burnt areas where the discharges have damaged the filters. But the scary part is that we have also seen filter elements that have been running for a very long time with ESDs, and at some point the filters are so damaged that the crackling stops, and because they are so damaged that the hydraulic load is going down, and letting everything through instead.
So it just bypasses, right?
Yeah.
Self, right? Yeah. Thank you, Saeed. And so let's, from a, let's say, step-by-step process, an operator hears, right, the crackling, or if they have a sight glass like that one video that you showed where they're seeing this stuff, and what do they do?
Yeah. Then you basically do a root cause analysis to figure out what's the source of the problem, because in a short presentation like this, the reality is never as simple as I try to tell you now. It can be quite tough to find the proper solution. So you also often end up with some different solutions, and you end up at trial and error. Basically, you have to check out what will work for you.
All right, and so when you do an RCA, what's the first step in that? Is it you pull the filters? Do you send an oil sample out?
Yeah, basically, we try to go out as wide as possible. Check. For example, we ask if we can take the earth bushings to our lab and inspect them with a microscope to see if the problem might not be arching from the oil, but arching from shaft to bearing. We go as wide as possible, and go in layer by layer after when we can rule stuff out.
Okay, and then in terms of like equipment application, does this occur mostly in turbines? You mentioned hydraulics. What type of hydraulic systems? Where will we see these?
Yeah. As we mostly work on heavy rotating equipment, that is steam turbines, compressor trains, and that kind of stuff. So, of course, our experience is very phased into that area. But when I started to look into this issue some years ago and start to talk to people around, found a lot of. It seems like this is happening basically in all kind of systems, from small hydraulic systems for valves to bigger hydraulic systems for loading boats and cranes, and yeah.
Wow.
What we've seen is we basically find it everywhere.
We have a comment from. So first of all, Rolf says, thanks, this is helpful. So thank you, Øystein. And then Luger's just making a comment here. So saying sometimes it's helpful to switch duplex filters to both filter elements if possible.
Yeah. As I said, that helps a lot.
Yeah, takes the load out. Excellent. And any other words to add, Øystein?
No, not really. I find this. I think this problem is a much more common problem than the industry itself thinks at the moment, and I think it will be an increasing problem in the future, especially with that the rate that the lube oils are evolving.
Oh, that's interesting, right? The more technology and refining we do to the oils, that will, you say, increase this phenomenon. That's interesting. And I think that's it in terms of questions from the audience. Øystein, thank you so much. This is a very interesting topic. And we thank you for sharing your knowledge with us.
Yeah, thank you.
All right. Thanks again. Bye, everybody.
Bye.